There's a plant that grows so fast that it seems to defy the laws of nature. It doesn't need to be replanted after each harvest. It adapts to extreme climates and can be transformed into a house, a utensil, paper, and even food. Its name, bamboo. While a tree can take between 30 and 100 years to reach maturity, some bamboo species achieve this in just 3 to 5 years. This rapid growth rate makes bamboo one of the most renewable natural resources on the planet. Additionally, its ability to regenerate without the need for replanting makes it even more efficient and sustainable. But that's not all. Bamboo is also a natural carbon dioxide absorbing machine. It is estimated that it can capture up to 35% more CO2 than traditional trees. What would happen if we replaced plastic and wood with bamboo in our everyday products? What if, instead of clearing hectares of forest to make paper, we used this miraculous plant? Every year, millions of tons of bamboo are harvested around the world. From Asia to Latin America, its cultivation has become a driving force for sustainable development. Flexible, strong, and above all incredibly versatile, bamboo has thousands of applications in homes, construction, and industry. Its impact is hard to overstate. Today, we'll take you on a journey to discover how this ancient plant has revolutionized entire industries. From its harvest in rugged terrain to its transformation into the object we use every day, what you're about to discover isn't just a production line. It's a veritable green revolution in progress. Prepare to dive into the amazing cycle of bamboo. We promise that by the end of this journey, you'll never look at this plant the same way again. Growing bamboo may seem simple, but its large-scale production requires thousands of years of expertise and perfectly coordinated logistics. In many parts of the world, bamboo plantations are located on mountain slopes, where access is difficult and the use of heavy machinery is nearly impossible. This is where human ingenuity comes into play. Farmers in these areas use traditional techniques, often passed down through generations. Armed with sharp machetes, they carefully select ripe stalks, distinguishing those ready to be harvested from those that have yet to grow. This selective practice is essential. It ensures that the mother plant continues to regenerate, thus avoiding overexploitation. Once cut, the bamboo is not left to rot. It is tied into bundles, transported on foot or on the backs of pack animals along steep paths to accessible areas where it can be loaded onto trucks. In some places, improvised pulley systems are even used to lower the bundles down slopes. This process may seem rudimentary, but it is perfectly adapted to the environment. In addition to its efficiency, bamboo cultivation has a positive environmental impact. Unlike intensive monocultures, these plantations can coexist with other plant species, protect soils from erosion, and improve air quality. Thanks to its dense, deep roots, bamboo is ideal for stabilizing land vulnerable to landslides. Unlike other commercial crops that require a lot of water and pesticides, bamboo is remarkably resilient. It can thrive in poor soils and variable climates, making it a viable option even in regions affected by climate change. And because it doesn't need to be replanted after each harvest, maintenance efforts are significantly reduced. This balance of tradition, efficiency, and sustainability has enabled thousands of rural communities to find a stable and environmentally friendly source of income in bamboo. But this plant's journey has only just begun. What follows is its transformation, a fascinating process where a simple stem becomes a useful, sustainable, and eco-friendly object. Once the bamboo is harvested and transported to the processing plants, an astonishing transformation begins, combining artisanal precision, hygiene standards, and technologies adapted to sustainable development. Each stem is evaluated according to its thickness, length, and density. Only the best are selected for food or high-performance products. The rest are destined for the manufacture of paper, textile fibers, or compost. One of the most common uses is the manufacture of disposable chopsticks. Every day, millions of units are produced in factories operating with extreme efficiency. First, the bamboo is cut into small sticks of uniform length. Then, a machine polishes the ends, removes imperfections, and rounds each piece with millimeter precision. Although it may seem simple, Behind it lies a complex industrial logistics process aimed at maintaining consistent standards of hygiene, speed, and quality. After molding, the baguettes undergo a critical disinfection step. They are briefly immersed in an antifungal and antibacterial solution, then dried in special high-temperature ovens. This process not only prevents the growth of bacteria, but also significantly extends the product's shelf life. Finally, they are individually packaged in biodegradable packaging or vacuum-packed in pairs, ready for global export. But the usefulness of bamboo goes far beyond that. The same raw material is used to make spoons, forks, spatulas, reusable straws, and even toothbrushes. To shape these objects, steel molds are used that apply pressure and heat to create ergonomic designs. Vegetable oils are then applied to waterproof the surface and protect it from wear. No harsh chemicals or synthetic varnishes are used, ensuring a natural and safe product. These eco-friendly alternatives are growing exponentially. Around the world, cafes, restaurants, and supermarkets are already replacing plastic with bamboo utensils. A plastic straw takes 400 years to degrade, while a bamboo straw only takes a few weeks. Additionally, its natural appearance and unique grain give it added perceived value among environmentally conscious consumers. This versatility also stimulates creativity. Some workshops design complete sustainable cutlery sets, including spoons, forks, knives, and straws, accompanied by a recycled fabric case. These products are a hit with students, travelers, and urban workers looking to reduce their daily ecological footprint. In addition, small family businesses have developed exclusive ranges of personalized utensils, using laser engraving techniques and natural pigments. This not only increases the aesthetic value of the objects, but also encourages local trade and the preservation of cultural identities. In Indonesia, India, and Colombia, this cottage industry has generated thousands of jobs in communities previously dependent on less sustainable activities. Bamboo products are not just an eco-fashion trend. They embody a new way of thinking about consumption, responsible, conscious, and in harmony with nature. They prove that it's possible to combine beauty, utility, and respect for the environment in a single object. And to think that it all begins with a simple stem silently growing at the top of a mountain. In the next part, we'll see how this same bamboo can even challenge industries like paper and construction, demonstrating that its potential is only just beginning. Bamboo's journey doesn't end with the kitchen. This ancient plant also has the power to transform the way we build and write. In the paper and construction industries, bamboo has established itself as one of the most versatile, durable, and environmentally friendly materials of our time. To produce paper, bamboo undergoes a specific process. Unlike trees, whose fibers are often thicker and more difficult to process, bamboo has a long, flexible, and very strong cellulose. These fibers are extracted by grinding the stem into a viscous pulp. This pulp is then washed, bleached without chlorine, and dried to produce soft, strong, and biodegradable sheets of paper. It is used for notebooks, napkins, packaging, and even toilet paper. In addition to its quality, it has a major advantage. While a tree takes several decades to regrow, bamboo can fully regenerate in just 3 years. This reduces pressure on natural forests and significantly reduces the ecological footprint of conventional paper. But its potential in construction is even more impressive. Its hollow, fibrous structure gives it tensile strength comparable to that of steel. In Asia and America, it has been used for centuries as the primary material for roofs, scaffolding, and walls. Today, modern architects are rediscovering it as an environmentally friendly alternative to concrete and brick. A single hectare of bamboo can provide enough material to build a 100 square meter house, while an equivalent project would require deforesting between 10 and 12 hectares of traditional forest. This difference not only means a lower environmental impact, but also lower costs and much shorter construction times. Compressed bamboo panels are already revolutionizing interior design. They're used for floors, walls, furniture, and even ceilings. They are durable, water-resistant, and aesthetically pleasing thanks to their natural grain. Additionally, they offer thermal and acoustic properties that improve home comfort. And bamboo isn't just functional, it's beautiful too. Its warm, organic appearance provides a connection with nature that no other material can truly emulate. In a world where construction is one of the most polluting industries, bamboo emerges as a tangible, renewable, and visually striking solution. It's a plant that breaks paradigms. Lightweight yet robust, fast yet durable, simple yet sophisticated. Its use in paper and construction illustrates how nature can offer us solutions to our most pressing problems if we learn to listen and collaborate with it rather than fight it. But beyond its industrial uses, bamboo possesses extraordinary ecological power. Its cultivation is not only efficient, it is also regenerative. In a world threatened by the climate crisis, this plant stands out as a natural ally for restoring environmental balance. One of its most notable benefits is its ability to absorb carbon dioxide. Studies have shown that it can capture up to 35% more CO2 than conventional trees. Planting bamboo is therefore about more than just avoiding emissions. This actively helps remove them from the atmosphere. In addition, it releases large amounts of oxygen, making it a natural air purifier. Its impact on soils is equally valuable. Its deep, extensive roots stabilize sloping land, prevent erosion, and improve soil structure. This is crucial in degraded areas or those subject to prolonged periods of drought. Bamboo can grow on poor soils, revitalizing them without the use of chemical fertilizers or pesticides. Because it doesn't require replanting after each harvest, it reduces soil depletion and limits human intervention. Its continuous growth cycle makes it a nearly self-sustaining plant, ideal for low-impact agriculture. This also reduces costs and facilitates its adoption by rural communities with few resources. Globally, the bamboo market is booming. Demand is growing in diverse sectors such as construction, fashion, biodegradable products, and even food. This economic growth translates into more jobs, greater energy independence, and a reduced dependence on polluting materials. Furthermore, bamboo fits perfectly with the principles of the circular economy. The residue from its processing can be reused as biomass, compost, or even transformed into biofuel. Nothing is wasted. Every part of the plant has a purpose, reinforcing its role as a comprehensive and efficient resource. Faced with climate challenges, bamboo is not a single solution, but it constitutes a powerful tool within a broader strategy. Its sustainable cultivation, combined with responsible environmental policies, can help us build a greener, fairer, and more resilient future. And the best part is, we're not talking about a distant promise, but a reality that's already underway. To conclude this journey, let's see how each of us can make a difference. Throughout this story, we've seen how a plant as simple as bamboo is capable of transforming entire industries, from chopstick making to sustainable housing. It's not just a raw material. It's a natural solution to many of the challenges our society faces. Bamboo embodies a new way of thinking about progress. Rather than endlessly exploiting resources, he teaches us to regenerate them. Rather than pollute, to purify. And rather than exhaust, to preserve. It is, without a doubt, a symbol of green hope. Now that you know its potential, the next time you hold a straw, a notebook, or a pair of bamboo chopsticks in your hands, remember that beyond this object lies an entire ecosystem functioning in harmony. And don't forget that there are also human choices that make a difference. Bamboo is already changing the world. Do you want to be part of this change too? If you enjoy discovering how nature can guide us towards a more responsible future, leave a like on this video, subscribe to the channel, and activate the bell so you don't miss our next documentaries. But be careful, that's not all. The rest of this video will be just as exciting, so stay tuned until the end.
There are industrial worlds that we think are reserved for the initiated, but which reveal a fascinating beauty and precision as soon as we take the time to observe and understand them. What you are about to discover here is one of those fields where the power of machines and human rigor unite to transform raw materials into forms of impressive precision. If you pay attention until the end, you will see how each step of this metallic journey fits into the next to give birth to creations that seem almost impossible to conceive, so perfect do they appear. Bending steel plates always begins with careful preparation to ensure a perfectly cylindrical and flawless result. A flat steel plate is prepared with a slight excess length on each side. This excess length is essential because it allows for precise edge preparation so that the steel can be rolled into a perfectly round shape. The edges of the plate are carefully chamfered to provide ideal welding conditions, a step that requires extreme precision to achieve a uniform and robust cylinder. After this chamfering, the plate is precisely marked to guide the cutting operations. This marking task ensures a perfect fit during final assembly. To facilitate clean cutting of the steel, the plate is preheated to an optimal temperature, which reduces internal stresses and prevents cracks. The result is a clean cut where the excess is removed and the weld edges are already formed. Once this step is completed, the plate is fed into a 320-ton Swiss rolling machine, a true mechanical monster designed to transform a flat plate into a perfect 276 mm diameter cylinder. The machine exerts a colossal but perfectly controlled force, ensuring a regular curvature without altering the structural integrity of the steel. Once the cylindrical shell is obtained, it is prepared for welding. The welds are made using the submerged arc method, which allows for very fast and consistent deposition thanks to the use of 2 filler wires simultaneously. A protective flux covers the welding area, preserving the quality of the bath. Any excess is recovered and reused, demonstrating an approach that is both efficient and environmentally friendly. The welded shell is thus remarkably robust and suitable for the most demanding industrial environments. But the show doesn't end there, because in the same facility is a press brake capable of exerting up to 3,000 tons of pressure on 8-meter-long plates, one of the most powerful in Europe. This colossal machine can bend stainless steel plates 60 mm thick and 7.2 m long, giving them precise radii according to the needs of the projects. Each bend is a demonstration of strength and technical mastery. And since sometimes it's necessary to go even further, a 43-ton steel plate, 150 mm thick and 2,230 mm wide, can be bent into a 5,000 mm diameter cylinder, an operation that illustrates the extreme capacity of this extraordinary equipment. Every phase, from edge preparation, preheating, cutting, rolling, welding to pressing, is carried out with absolute coordination and rigor that guarantees the reliability of the final pieces. And this is where I pause to tell you something important. If you enjoy learning about these unique industrial processes and want to support the creation of this kind of content, simply click subscribe and activate the bell so you don't miss any of the upcoming videos. I assure you that what you're about to see next is definitely worth staying tuned in. The manufacturing of pressure vessels begins with the selection and preparation of steel pipes and plates. The pipes are cut to precise lengths using automated machines, and each piece is then numbered and marked to ensure complete traceability during assembly. Welds are made using rod and MIG processes. Rod is preferred for fine detail and precision, while MIG provides strength and speed. Each joint is welded from the inside and outside to ensure perfect resistance to high pressures. After welding, the parts are assembled with a precise fit to ensure the tank is completely reliable. Then, laser technology comes into play. Laser markings engrave and code the covers, ensuring traceability and facilitating quality control. Laser cutting then shapes precise openings to accommodate pipes, valves, or sensors, limiting additional finishing. These cut plates are then folded by 3 roller machines to form perfectly fitted cylinders for subsequent assembly. Each step is accompanied by strict quality controls based on European regulations so that the final products can be used safely in the chemical, pharmaceutical, and food industries. The manufacture of welded beams begins with digital nesting, which optimizes plate cutting to reduce waste. CNC plasma or oxy-fuel cutting then produces elements with exact dimensions. These pieces are deburred and ground to remove any defects. Then they are tack welded to maintain their alignment before complete welding. Cuts and adjustments are made to ensure a perfect fit. Then the welders continue to create solid beams that meet structural standards. A gouging process cleans the welds and prepares the areas requiring correction. Finally, a mechanical or thermal straightening process ensures the beam's straightness. Quality controllers check the straightness, dimensions, and finish before approving the final product. In heavy-duty steel mills, steel slabs are heated in furnaces to rolling temperature and then passed between powerful rollers that reduce their thickness and give them the desired dimensions. Steel piles are formed in specialized rolling mills, which give them interlocking profiles suitable for foundations. Oxy-fuel and plasma cutting are used to create complex shapes according to customer drawings, and each piece is then deburred and inspected. Ductility tests on spherical blanks are performed using hydraulic presses that apply progressive force to form rounded edges and assess the strength of the metals. The 4.5-meter dished heads are formed by cold singeing on forming machines equipped with powerful rollers that gradually descend onto the rotating part. This method ensures high precision even on large parts. At CAH Bastille, a heavy-duty forge produces ingots of up to 600 tons thanks to 150-ton electric arc furnaces, vacuum degassing, and 13,000-ton hydraulic presses capable of shaping gigantic parts for the energy, nuclear, and marine industries. The 60-ton electric arc furnace melts scrap metal using electric arcs between graphite electrodes, generating temperatures exceeding 3,000 degrees Celsius, enabling efficient and sustainable recycling. Spiral boxes for hydroelectric power plants are machined, welded, straightened, and heat-treated to ensure dimensional accuracy and mechanical strength. Hydraulic rollers weighing almost 900 tons bend 70 mm thick and 4.5 m wide plates with perfect regularity thanks to CNC control. The 4-roll double-nip machines produce cones and cylinders with exceptional precision. 750-ton mechanical presses form spherical plates for large-capacity tanks, ensuring regular, standard-compliant curvatures. Ultrasonic tube inspections continuously measure wall thickness using frame and C-frame systems that guarantee perfect homogeneity. At every stage, continuous dimensional monitoring allows for immediate correction of any variation and delivery of products that meet the most demanding standards. This journey to the heart of steel transformation demonstrates how the power of the machines, the rigor of the operators, and technological innovation combine to create gigantic yet surgically precise parts. If you enjoyed this immersion into the world of monumental machines and incredible industrial processes, don't forget to subscribe and like this video because what awaits you right after is even more impressive.